Okay, guys, let's talk about the the ways that differential equations will show up on your Calc 2 test. There are four main things that have happened over the years. Two of them you already should be pretty familiar with after some review. Separable differential equations are old. Slope fields are old. Euler's method, it looks like I know Euler's, but it's pronounced Euler's, and logistic differential equations are new topics. And we're going to start today with logistic differential equations. Um, so along the way, I've been telling you there's a few topics that we haven't learned. This number 1 and number 4 are those topics, and once we get through those, you'll know everything you need to know for the test day. So let's start today with logistic differential equations. Okay, this you need to know. Make sure you've written this down. The basic form of a logistic differential equation looks like that. As we will talk more about, a differential equation is an equation with a derivative in it. That's all you need to know. And this dy dt could look like y prime in certain circumstances. That's another valid form. And these are, a little bit confusing, but the way that they're going to ask us questions about this shouldn't be confusing. There's only a select few ways that this will come up. K is a proportionality constant that would just make the equation fit to the unique situation that it's modeling. Y is just Y. It could stand for, in our example, it's going to be how many people have heard a rumor. It's just Y like XY always has been, or Y and T in this case, but it's just the number of people in our example who have heard this rumor. A is the max value. Another word is carrying capacity. If you have a bunch of a certain kind of animal living on an island, that would be the number of animals that could live there and not steal each other's food, or the number of total people in your school, because no more people can hear the rumor than there are at the school, if that's your definition for Y. Anyway, what you need to do with this form is either recognize that it's already in this form or make it look like this form. It might take a little bit of factoring, and we'll see some of that with an example. Basically, what logistic differential equations model is the spread of a rumor or the growth of a population or something like that, where there's a limit. Some stuff grows exponentially, like your retirement fund hopefully is going to grow exponentially, or the population, so far the population of the world is kind of growing exponentially. At some point it's got to level out. So what a logistic equation does is it shows us how the population levels out. So let's say that this graph represents the number of people in your school who have heard the latest rumor, and you know how rumors can spread. What happens essentially is that it starts out with a few people, and over the first few days it starts to grow slowly, and then it starts to grow really fast and get really steep as a lot of people are hearing. However, once you cross the halfway point where half of the school has heard the rumor, it has to start slowing down, because certain people tell people who have already heard, and it starts being a juicy rumor and starts being old news. So what happens at that point is it starts to level back out. The exponential growth goes away, and we start to approach our carrying capacity. So this is the basic form of what a logistic graph looks like. And there are only a few questions, and they're all easy questions about um, about these that they can even ask us. So let's go through the possibilities. Okay, there are four things that they might ask you to do, and here they are. Make sure you write down this list. Make sure you have this general form in blue written down, what the constants mean, and just a sketch of the graph to kind of get an idea of what we're talking about. Here is the list of things that I have seen in all of the AP materials I've ever looked at. These are the four things that I've ever seen them ask about a logistic differential equation. So it's kind of like this advanced high topic, where it seems like it should be difficult, but they're only going to ask you some very basic things. First of all, you need to make it look like dy dt equals ky times a minus y, which usually is just going to require a basic little factoring. And the ky in there for Kentucky might help you remember that, just in case you're having trouble remembering. Next is find the limit of y as t approaches infinity, which all they're asking us there is how many people are in the school, or how many rabbits can live on the island, or what's the carrying capacity. And once you have it solved and make it look like ky times a minus y, then that's easy. It's just as easy as looking at your equation and seeing what's in the spot where a is right now. Next, they're going to ask you possibly when is it growing fastest, and that is going to be half of a every time. If there are 2,000 people in your school, then it is growing fastest when 1,000 people know. If this island will hold 300 rabbits, then the population is growing fastest when there are 150 rabbits. When half the possible population is there, that's when it starts slowing down. Rabbits start competing over the same food, or people start telling the rumor to people who have already heard it, and it doesn't grow so fast. And the last thing I've seen is they give you 3 and ask you for the 4th, and it's just basic algebra. So let's do this one example that I've cut from some other review sheet, and I'll show you how easy these are. First of all, we have, this is the growth rate of a monkey population in a wildlife preserve. So, you know, monkeys start reproducing rapidly at first, but after a while they're trying to live in the same trees and eat the same fruit, so they don't grow so fast. And it just kind of levels out with the right amount for that area. How many monkeys can live in the preserve? So that's our question, basically, is what's the carrying capacity? And if you can just make it look like it's supposed to look, then these questions are all very, very easy. So we just need to factor out and make it look like ky times a minus y. In this case, p. So I want to make it look like dp dt equals kp times a minus p. All I've done is change my y into a p. So that's just going to require factoring out the p along with the constant so that just p is left. All right, I need for this term right here, after I factor out, to be just p. So I'm going to factor out 1p along with 0.0004. In order for that to happen, I need to know what 0.2 divided by 0.0004 is. So I'm going to check that. And it turns out that if we factor out the 0.0004 and the p, we will be left with 500, because when you factor out, you divide, and 0.2 divided by 0.0004 is 500 minus p. All right, and you can double check your work by just distributing that back in to make sure that it works. So my k, 0.0004, that's the constant that makes this equation fit this monkey situation, but it doesn't really have anything to do with the questions. P is the population at a certain time, and A is 500. So how many monkeys can live in the preserve? 500. At what point is the population growing fastest? When there are 250. All right, it's just as easy as that. If you can remember the form ky times a minus y, and you can make it look like that, then any questions that they can ask at that point are easy questions. So that's logistics, just like UPS. All right, if you can do these things, most importantly, if you can remember this form, understand the kind of questions it's going to be about, and then make it look like that form, like we did here, then the questions are going to be easy. All right, so there you go. There's our cram course on logistics. I'm out.